Today we're going to be doing adding and subtracting polynomials. So you'll need your yellow chapter or unit 6 packet, and we start on page 12. So all we're going to be doing is basically what we've done before. We're combining like terms. So if we look at example 1, it says find the sum of the polynomials. So I can see there's two things in parentheses, and I see the plus sign in between, so I know that I'm adding. All you're doing is combining like terms. So if you notice, I have an exponent with a 2 over here and another one with a 2 over here. They're y squareds. I'm going to combine them because they're to the same power. So the 7y squared and the 5y squared, they're going to get added together. When you add them, you only add the numbers in front. So I'm going to add the 7 and the 5. That makes 12. You leave the exponent alone. So this stays y squared. Then I like to go down the exponent. So since I had y squared, then I would go to the y's. So I have a positive 2y and a negative 4y. You always look at the sign in front. So 2 minus 4 is negative 2, so it would be minus 2y. And then I have the negative 3 and a positive 2. So negative 3 plus 2 is negative 1. After here, I'm done. I can't combine any of these terms because they don't have the same variable to the same power. So this is my answer. So if I look at B, I'm going to do the same thing. I'm going to start with the highest exponent. So the highest exponent is an x squared. So I have 4x squared and a negative 7x squared. Remember, we always look at the sign in front. So 4 plus negative 7 is negative 3. So I have negative 3x squared. Then I go to the x's. Negative 2x and positive 3x. Negative 2 plus 3 is positive 1x. Then I go to the regular numbers. 7 and negative 9. 7 plus negative 9 is negative 2. Now I'm done. So C and D are the exact same. So if I go over here, I notice my highest exponent is a 2. So 5x squared, negative 3x squared. 5 minus 3 is 2, so I have 2x squared. Then I go to the x's. Negative 3x, positive 6x. Negative 3 plus 6 is positive 3x. And then my regular numbers. Positive 4, negative 3, 4 plus negative 3 is positive 1. Notice again that I've never changed the exponent. I've only changed the numbers in front of the exponents. So when you're adding and subtracting polynomials, okay, you only change the numbers in front. So my last one for this example, so I notice my highest exponent is a 4, so I'm going to start there. This y to the fourth, remember, even if I don't see a number in front, it means that there's one of them. So y to the fourth and negative 2y to the fourth. So 1 plus negative 2 is negative 1. So it's negative 1y to the fourth. Then I would go to the third power. I see I have a 2y to the third power. That's the only y to the third power there is. So I can't combine anything, so I'm just going to rewrite it. It was positive, so that's why I'm putting plus 2y to the third. Now there's no y squared, so I'm going to skip that and go to just the regular y's. So I have a negative 3y and a positive 2y. So negative 3 plus 2 is negative 1y. And then I go to the regular numbers. So I have 7 and negative 11. So that makes negative 4. Again, none of these can be combined because now, right, they all have different exponents, so they're not like terms. So that was adding polynomials. Now we need to subtract them. The difference with subtraction is that I can't just combine like terms as it is. Remember, when you see a minus sign and then a parentheses, it's really like we're distributing a negative 1 to every term inside. So the first thing I'm going to do is distribute the negative sign. So this means I have a negative 9y to the fourth, a positive 7y, and a negative 2y squared. The parentheses in front, right, there's no negative out there, so I don't change anything about this. So I'm just going to rewrite it. And now it's exactly like our other examples. So the highest exponent I see is 4, so I'm going to start there. So 8y to the fourth and negative y to the fourth, or sorry, negative 9y to the fourth, makes negative 1y to the fourth. So I start with negative y to the fourth. My next highest exponent is squares. I have 6y squared and negative 2y squared. That makes positive 4y squared. And then I have my regular y. So negative 5y and positive 7y makes positive 2y. And now I'm done. So I do the same thing for b. I distribute the negative sign. So it's like I'm distributing a negative 1. So this would be a negative 4n, a positive 3, and a negative 5n squared. The other parentheses, the one in front, just going to bring down these numbers. And then now I'm just combining my like terms. My highest exponent is to the third power. This is 11n to the third. It's the only one, so I just rewrite it. Then I move to the squares. 6n squared and negative 5n squared make positive 1n squared. Then I go to the regular n's. So 2 and negative 4 make negative 2n. And then the plus 3, that's all by itself. So I just rewrite it. Plus 3. 2 more. I distribute the negative sign. So I have a positive 2x cubed, a negative x squared, and a positive 2. But I'm going to bring down the 4x cubed, the minus 3x squared, the plus 6x, and the minus 4. Now I'm combining like terms, so I'm going to do this without the shapes this time. So 4x cubed and 2x cubed make 6x cubed. Negative 3x squared and negative x squared make negative 4x squared. 6x, that's the only regular x, so I just rewrite it. And then negative 4 plus 2 is negative 2. Last one for this example. Distribute the negative sign. So this is a negative 7, a positive y cubed, and a negative 12y. I bring down the 8y minus 10 plus 5y squared, and now I'm combining like terms. The highest exponent is the y cubed, so I start there. There's only one of them, so y to the third power. Then I have 5y squared. There's only one of those, so plus 5y squared. Then I go to the y's. 8 and negative 12 make negative 4y. And then my numbers. Negative 10 and negative 7 make negative 17. So example 3 on the next page is just a bunch of different examples with addition and subtraction all mixed together. So I always look in between the parentheses and see what's there. So this is the plus sign, so I know I'm adding. I look, my highest exponent is a cube, so p to the third power, so I start there. That's the only one, so I have negative 3p cubed. The squares, 5 and 2 make 7, so plus 7p squared. And then minus 3. So b, this has a subtraction sign, so I'm going to distribute that. So I have negative 3n to the third power minus 4n. The front parentheses I'm just going to rewrite. And then I'm going to combine like terms. So I'm going to start with the cube. Negative 3 and negative 3 make negative 6. So it's negative 6n cubed. 4n and negative 4n make 0n. Remember, any number, so any variable times 0 is still going to be 0. So I'm not going to write plus 0n. This is just my final answer. C, I see its addition, so I don't have to distribute. I can just combine. So I see that the fourth power is the highest, so I start there. Negative 4 and negative 3 make negative 7. Then the next highest is the squares. 3 and negative 14 make negative 11. And then 14 minus 8 is 6. D, distribute the negative. So I have a positive 6n to the fourth, a positive 3n, and a positive 8n to the fifth. I bring down the first parentheses, and then I go ahead and combine. So my highest exponent is the 5. 8 and negative 6 make 2. The 4's negative 8 and 6 make negative 2. Then my next highest exponent is just the n. There's nothing to combine it with. And then I have a regular 3. There's nothing to combine that with. So here's E, F, G, and H. Okay? If you'd like to, you can go ahead and stop this and try it on your own and then check your answers. Or I'll keep going explaining everything through if you want to follow along if you don't understand it yet. So E, it's a plus, so I don't have to do any distributing, so I just combine like terms. Start with the 5's. 13 plus 5 is 18, so I have 18x to the fifth. Then move to the 4's. Negative 1 and 7 make a positive 6. Then I go to the 3's. 6 and 6 make 12. So it's 12x to the third. Over here, I distribute the negative. So I have negative 2x to the third minus 8 plus 4x to the fifth. So you're basically changing the sign of everything. Here's 7 minus 13x to the third minus 11x. Now I combine. 4x to the fifth is the only one. Then I move 3 is the next highest. Negative 13 and negative 2 make negative 15. Then the next are my regular x's, so I have minus 11x. There's nothing else to combine. And then I have 7 and negative 8, which makes negative 1. Last two for these. So G is on plus, so I just combine like terms. Highest exponent is the 5. There's only one of them, so I start with negative 8k to the fifth. Then I go to the 4's. There's two of those. So 1 and negative 5 make negative 4. Then I go to the 3's. Negative 3 and positive 6 make positive 3k to the third. Then I go to what's left, the minus 3. Last one. Distributing the negative. So I have a positive 14, a negative 5p to the fifth, and a positive 11p squared. I bring down the 14p to the fourth, the 11p squared, and the minus 9p to the fifth. And then I combine. So I start with my 5's. So I have negative 14p to the fifth. Then I go to the 4's. That's the only one, so plus 14p to the fourth. Then there's no 3's, so I go to the 2's. 11 and 11 make 22, so plus 22p squared. There's no regular p's, there's just the 14 left, so plus 14. So the last example, example 3. This says the total amount of toy sales in billions of dollars consists of two groups: sales of video games and sales of traditional toys. In recent years, the sales of traditional toys and total sales can be represented by the following equations, where n is the number of years since 2000. Write an equation that represents the sales of video games V. So what you're going to do, we know it says that total toy sales, which is represented by T, consists of video games and traditional toys. So what we're going to do is we're going to write an equation. I know that my total sales comes from the sales of video games and traditional toys. So it would be T equals V plus R. Since I'm given T and I'm given R, I want to find V. This is where we use our literal equation skills. If I need to find V, I want to get this alone, I would subtract R from both sides. So I know I can get the video game total by taking the grand total minus the traditional toys, minus R. Well, I've got these polynomials that represent this. So what I'm doing is I'm taking the total sales, so the 0.45n to the third minus 1.85n squared plus 4.4n plus 22.6, and I am subtracting the R, the traditional toys, so 0.46n to the third minus 1.9n squared plus 3n plus 19. So even though there's decimals, this is still the same process. So I'm going to go ahead and I'm going to distribute that negative sign to all of the terms in the second parentheses. So what I have is negative 0.46n to the third plus 1.9n squared minus 3n plus 19, or sorry, minus 19. So I'm going to combine like terms. So I'm going to just do this from here because I'm running out of room. So I would take 0.45n cubed minus 0.46n cubed, which is negative 0.01n cubed. Then I go to the squareds, negative 1.85n squared plus 1.9n squared, which is a positive 0.05n squared. And I go to the ends, 4.4 minus 3 is positive 1.4. And then I go to the regular numbers. 22.6 minus 19 is positive 3.6. So here is my equation. Now part B says use the equation to predict the amount of video game sales in the year 2009. So remember that N stands for the number of years since 2000. So since from 2000 to 2009, it's been 9 years. My N equals 9. So all I'm doing is I'm taking the equation that I just wrote up here, and I'm replacing the N's with 9. So it's negative 0.01 times 9 to the third power plus 0.05 times 9 squared plus 1.4 times 9 plus 3.6. So I go ahead, I just plugged all of that into my calculator, and I got 12.96. Now we're talking about billions of dollars. So they made $12.96 billion from video games. That was adding and subtracting polynomials. Now you're going to go ahead and go to your blue packet and start your homework. The sub will tell you what page that's on.